My name is Ben Motz. I'm from the Department of Psychological and Brain Sciences at Indiana University. I want to start kind of as others have by telling you a little bit about myself. My jam is to test learning theory in naturalistic education settings. And rather than just saying that out loud, I figured it'd be helpful to give you some examples. So sometimes my work is super niche. For example, I'm just doing a project right now led by my grad student, Olivia Gatto, looking at what kinds of communication strategies surgeons use when they're training other surgeons on how to perform robotic surgeries. So like we're looking at robotic radical prostatectomies and how an attending will teach a medical resident how to do it. And it has certain affordances, this particular thing, like that they're looking at the same thing. So if they're in these Da Vinci machines, they're seeing the exact same visual input. It's a typified procedure. So a lot of things are really well controlled, and it's neat. And if you're interested to hear more about that, we'll be presenting it on Saturday. And sometimes my work also aims to be pretty broad. So I just recently completed a study where we looked at the effects of pre-questions. These are questions that students answer before they learn something, which is totally weird because they don't know the answers to the questions. We looked at how that affects student learning and behavior across dozens of dissimilar classes, ranging from like 6th grade Spanish all the way up to college senior level business statistics. And to do that kind of work, I, with other colleagues like Rob here, have pioneered a model for doing research that we call many classes, and I'll talk a little bit about that during Judy's symposium at Coxsackie. And sometimes that work is super hard, so I also build infrastructure for this work. I lead a project called Terracotta. Terracotta is an A/B testing tool for Canvas. I'm locked in a death match with Jim and G about who will be the infrastructure that wins. That's actually, I was going to say the exact same thing. No, there's room for more than one infrastructure, thankfully. We don't need to just have one space telescope or one ISS or anything. Okay, but if there is time left, then I'll tell you a little bit about Terracotta. But instead of talking about the stuff that I actually know things about, I want to step out of my comfort zone and tell you about a project that I've just recently kind of wrapped up, and I'm really excited to get your feedback on it. So this is stuff that you know more about than I do. We've just done a research study on visualizations of uncertainty in an online decision-making study. And I'll tell you what we found to start. So people aren't very sensitive to uncertainty. That's kind of already known. But one of the things that's interesting from my perspective about it is they don't simply ignore it. It's not totally like knowledge that they don't even think about. And also one of the things that are really interesting for the context of this workshop is that the sensitivity to uncertainty, which we're trying to quantify in this study, is totally uncorrelated with things like expertise in the decision domain, also uncorrelated with highest level of statistical training, also uncorrelated with self-reported comfort level with statistics. So it seems to be really fascinating in the context of research that we've been hearing about here, like finding that performance on common visualization literacy assessments turn out to be correlated with something like math savvy. So there's something weird going on. Maybe our current visualization assessments are incomplete, or maybe there's other things that are not assessed that also people don't do very well and that normal statistical training isn't really helping with. So I'll come back to that. But let me tell you a little bit about the motivation for the study in the first place. So I'm really involved in things like science of learning, and for a while I was deeply involved in like departmental administration on teaching. And this study came out in 2015, and it kind of made a small splash in the literature on student evaluations of teaching. So this guy Boyson, was interested to know how people interpret really small differences in student evaluations of teaching. You know, this is like at the end of a semester when you evaluate your instructors on how they did and stuff. So he presented participants, and in this case, participants were real college faculty members. So these are not like prolific or even students. And he presented them with the display that you see at the top, where an imaginary instructor has ratings for 3 different courses. There's the instructor's means and the corresponding confidence intervals for those means from the ratings observed. And then the departmental mean and the confidence interval for the departmental mean, and even annotated each of them with the statement, not significantly different, and then administered these questions to the participants, basically asking what the instructor should work on improving, and found that there was a statistically significant tendency for people to more strongly agree that the course that had the lowest evaluation ratings should receive more attention. And that was interesting because if you look at the data, that course is higher than the departmental mean, so it's directionally better than his peers, and also all the confidence intervals overlap everything. And it's annotated with not significantly different. So it's really fascinating that people seem to be drawn to this. Also, there was a follow-up study, which I'm not going to tell you about, which found that when they administered this just to departmental chairs, like people who are actually making decisions about things, and the test wasn't just what the instructor should work on improving, but how to allocate teaching grants, they still showed the same bias. So it seems to be pernicious even in like real decision-making contexts. So given all this information and the splash that it made, me and some colleagues decided to answer this not lofty question at all: are decisions influenced by uncertainty? And really there are two competing views on this. On the one hand, classical psychology might say not really. So in like good old-fashioned decision-making tasks, like some that Mary mentioned, like Kahneman Tversky in 1979, but others more frequently, people frequently downweight the likelihood of choice outcomes and instead just focus on the outcome itself. So it's like they don't really care that much about what the likelihood of the thing is, just what it is that they're making the decision on. And that's been usually done with numbers. There's been research more recently that many of you have actually been involved in that's been showing that if you do it as a visualization, if you actually have like a graph or something, it doesn't get much better. So when estimating probabilities, participants tend to prioritize means and disregard uncertainties. And also if you were to put like a summary mark, like a mean mark on something that otherwise showed uncertainty, then it causes people to maybe discount uncertainty. So yeah, one side of the coin, on the one hand, you could say not really influenced by uncertainty, but it's also the case that there are literatures that show that dot plots and histograms can lead people to better account for uncertainty. So it's not a categorical rejection of uncertainty. If you represent things as frequencies, then it might be the case that people suddenly magically become sensitive to uncertainty. And moreover, there's this cool research, I don't know if you guys paid attention to this one, but on consumer psychology, on how people's purchasing decisions are influenced by consumer ratings that are out there in the world, like on Amazon or something, or movie critic ratings. And that finds that people are actually sensitive to uncertainty when it's even communicated as numbers. Like there's a study that looked at movie critics and found that people tend to prefer movies that have high variability in the critics' ratings. And yeah, in real world markets like on Amazon, so I understand that G just came out with their first romance novel, and it turns out I don't know if you can rate it before you buy it, but if you can, then give it really high variability ratings. But because it turns out there's like all this interest in niche, yeah, niche romance novels. Okay, we decided to explore this. So what did we do? We presented participants with a series of choices, and participants were randomly assigned to one of 6 different visualization conditions. On any individual trial, they were asked to tell us what they felt between A and B, and I'll tell you a little bit more about our dependent variables. But you can see that on the one extreme, we've got something like a control where there's no presentation of variability at all. It's just the mean. There actually is variability underlying in the data. So it's the case that sometimes the variability is high and sometimes it's low. But in that case, it wasn't visualized. It was just the mean. And then in other cases, we were showing the standard deviations numerically. And then we had these additional visualizations where we were representing the data as histograms and as means with the corresponding credible intervals. I was working with John Krushke. I'm not going to get into statistics, but it was very Bayesian. And this one was fun. This was the difference of means. So if we just wanted to see which instructor was better, then you can imagine taking the difference of the 2 different ratings and then having a corresponding credible interval around that too. Does that make rough sense? Okay, and then what did we measure? So on every trial, participants are faced with a decision between A and B, and so far you've seen instructors, but there were 2 other domains. We also had restaurants and online products. Domains were presented in blocks, block order was randomized. So trials varied by whether there was higher ratings on the thing on the left A or the thing on the right B, so we did randomize that. The difference between A and B, like the mean difference between them, but critically, the standard deviations of ratings. We had a condition where it was large and a condition where it was small, and also the number of ratings, which I'm not going to talk about because that would take too long. And then additionally, we included just some catch trials where there was no difference at all, just to make sure that people also weren't just responding, whatever. There were 10 trials per block. This all took about 20 minutes. We recruited our participants from Prolific. I told you my jam was doing things in classrooms, but unfortunately we don't teach any classes specifically on making decisions between instructors. So this is like a lab study, but I could imagine cool studies later on. We threw out participants who didn't make a choice that was consistent with the ratings on at least No, that's not right. On greater than 10. Actually, no, that's right. So we wound up with about 520 participants because some people were just not making things that made sense. This was from prolific, so it was slightly older than a normal subject pool population. And yeah, one of the interesting things is how much stats background they had. About half of the sample had like no college stats. Okay, I'll show you some data now. Simple one is mean differences. So what you're seeing right here are density plots showing the slider positions for the first two questions. The first question, remember, was what option would you choose? And then the second question was how confident are you? And for the top plot, what I did is I realigned the data so that the thing on the right is always the superior option. Okay. Comparisons with a small mean difference are shown in blue, and comparisons with a large mean difference are shown in this pinkish, peachish color. And what you're seeing are huge, whopping, substantial differences when we vary the means. That should be totally intuitive. If this thing is categorically better than this thing, then people should like it better. And it's not just that they like it better, it's also that they're more confident in their responses. You do not need statistics to show these are huge differences, okay? So what would be perhaps more interesting is to see what happens when we vary the standard deviation. So these are the slider positions where we vary large and small standard deviations, and you can see that these overlap a whole bunch. So basically, when standard deviation increases, you should expect that people will suddenly be less strong in their preference for the better thing, and that maybe they would be less confident in that response, but they're kind of not. But I say kind of not because actually, the data look like there's hints of directions that are consistent with that interpretation. Like there's more pink down here. As you get larger variance, more uncertainty, then people do seem to maybe get a little bit less strong in their preference, or maybe a little bit less confident. And it turns out that those are credibly different from zero difference, the peach and the blue here. So let's dig a little bit deeper in what goes on with the different visualization conditions. Okay, to orient you to this new plot, I'm gonna show you change in preference with decrease in SD. So as we go from high SD to low SD, we should expect people to become stronger in their preferences because all of a sudden people become more consistent. This is what we would call sensitivity. It comes back to sensitivity. So this is like sensitivity to variability. And the gray bar around zero, that's our rope. That's our region of practical equivalence to zero. Again, we're very Bayesian. So what you see with the control condition, when we don't present variability, there's no influence of variability. Great. Okay, so that's going to be our benchmark. If we then introduce SD, what we see is practically no real change in people's sensitivity to variability. So introducing SD, even though it's there, people aren't really affected by it. There's a slight shift, but it's not credibly different. Okay, and then also if we include N, it doesn't get any better, it doesn't really get any worse. There's still a lot of overlap. But then, if we have a histogram, everything's different. So suddenly people do seem to be not just a little bit, but relatively strongly affected by changes in the standard deviation of ratings in the direction that we'd expect. As ratings become more variable, they become less strong in their preferences, or conversely, if it becomes less variable, they become stronger. The thing that was interesting to me is that this it wasn't zero when we just showed error bars around the means. So it's not the case that people suddenly disregarded error bars. We still saw a credible difference when we represented things with dots with error bars around them. And also the difference plot. For the record, we were really hoping this would be the best one because this is the most intuitive one from my perspective as like somebody who looks at these data. Like you could even do a direct mapping between this plot and the response options. Like if instructor A, then the difference from zero could be like the answer to the first one and the size of the error bars could be your confidence, but no, people aren't that sensitive. Okay, but it wasn't zero. There was no, it wasn't the case that people ignored the size of the error bars there. Okay, and I'll show you the answers to the confidence question now. So it's the case that it's not as beautiful in terms of overlapping with zero. That might just be random variance that causes it to be slightly up. But we also see no real change when we introduce SD in terms of people's confidence. When we introduce SD and N, no real change. And then when we have the graphical visualization conditions, suddenly we see it go out from the rope. Okay. I'm doing great. This is, okay. Let me tell you about these measures and how they correlate with statistics training and comfort. So I told you before that most of the participants, or about half of them, had no real undergraduate stats. And I also had the question of like, how comfortable are you with statistics? And most of the people were not super comfortable. There was only 1% of the population who said complete comfort. So there was no effect of statistics training or comfort on any of the measures that I've described, and there were many of them. You would have thought just by random chance alone that we would see like something popping out and then we could write a paper on it. But no, it's not the case that statistics training or comfort moderated any of these dependent variables. And there was also no stats background by visualization condition. So it wasn't the case that like stats training suddenly made people better with histograms, but nothing else. And in fact, I want to show that data to you because it's one thing to say there's no interaction. If you're like me, you'd be like, but maybe there was, and just interactions have higher requirements for statistical power. No, this is like a giant nothing burger. So yeah, as you get more stats coursework, but it's the exact same thing with comfort level, people's sensitivity, again, their change in preference, but you could do the same thing with confidence. Their change of preference really has no change across the board. So it's not the case that students are collecting out of our statistics coursework or out of their high school statistics coursework or even out of their graduate statistics coursework, any sort of change in their sensitivity to how error bars represent uncertainty and how they take that into account when they're making decisions. So to summarize, there was past research that suggested that when estimating probabilities, participants tend to disregard uncertainty, and if you have point summary marks, then people might also disregard uncertainty, and that basically checks. So we see a giant, robust main effect of mean differences and very small main effects of variability. But it's just not the case that people totally neglect it. So it's not the case that people are unaffected by changes in the standard, in the standard deviation or the size of the error bar. Specifically, when ratings data are visualized with a histogram, sensitivity is really big. So there's lots of potential reasons for that. We could unpack that in conversations right now or at dinner or whatever. So it could be better reasoning about frequencies, which is, I think, in the literature, the most commonly cited thing. But I don't think that's the only possible explanation. It could be that when you've got a histogram, the variability just occupies more visual space. Like there's more visual stuff happening around SD than if it's represented as the size of these narrow error bars. In talking about this with other people who are not in academia, they always say, oh, I'm just used to it from Amazon. Like Amazon shows histograms, and maybe it's the case that people have experience reasoning with histograms that they don't have with error bars. So we do see credible sensitivity to SD when it's shown with error bars, although the effect is smaller. There's no influence of uncertainty when SD is shown numerically, and there's no influence of stats training or comfort on it. Okay. So those are the general takeaways from the study, but I think for this, I want to go back to this idea that performance on common visualization literacy assessments are well correlated with math training. One, sensitivity to uncertainty in data visualizations is uncorrelated with stats training. I don't have math training, but we actually validated our stats training questions. We also asked a few stats questions in the study and found that those tracked. So really it's the case that how much you know about stats doesn't affect what you think about with respect to uncertainty. So in considering new assessments of data visualization literacy, if that's on the table, maybe something about uncertainty would be cool. I think so. That's my plug. And also, not just assessing it, it'd be cool to explore whether novel interventions or scaffolding or training might increase participants' sensitivity to uncertainty. I think that'd be dope. How might that work? Well, again, I told you if there was time, is there time to just briefly mention Terracotta? So, hi, I'm Terracotta. If you're used to Canvas, then you can imagine Terracotta being something that could be plugged into your Canvas course site as a teacher, and it's then giving you an experimental testing suite for learning activities. To fast forward to what it might look like if you were running an experiment in Terracotta, there's a page that has the experiment status. And within that, there's a few different things. First, there's a Canvas assignment, which in this case I've called assignment 1. That works. Yeah, I like naming things well, but I can be vague too. Within Canvas 1, there are different versions. So what a student sees as assignment 1 can be randomly assigned or it can be manually assigned to different students. Then Terracotta, if you wanted it to be random assignment, Terracotta could automatically manage randomization. I know that randomization is something that you can do manually in Canvas, but it creates all sorts of big problems. Like if students add the class late, if you're manually doing randomization, then it could be that you just miss a student and then they don't get any of the learning activity, which is a big problem. Or a student drops the class, but they're stuck in your class because you assign them to a section or an assignment or something. It also allows repeated measures. It's not just one assignment. You could have many assignments throughout the semester. You could do a semester-long experiment. It gives you the data easily. Jim was right. Getting data out of data platforms sucks. So Terracotta tries to make that modestly easier. And another thing about it, we haven't really talked about ethics with education research, but I think it's a big deal. And Terracotta takes care of research ethics with students really well. So it has a whole informed consent pipeline where you could take a student and say, here's an assignment to answer an informed consent question, and then they could agree or not agree. Last thing that I'll say about it is that Terracotta doesn't just require you to build stuff in Terracotta, you could build something somewhere else. So if you had a simulation, like with armadillos or with something else, then you could easily make it so that if you've got a web page, it's now an assignment in Canvas and students get credit within the normal coursework that they're doing otherwise. So just to be clear, if you made like a little simulation saying, hey, I want to help students run a simulation of how they might understand uncertainty with error bars, then Terracotta makes it so that you could deliver that not just as an assignment, but as a condition in a randomized controlled trial experiment in the course. So that's my jam. That's it. Thank you.
I was just going to ask, does Terracotta yet allow you to launch an experiment in more than one class? Or is it always within that class? And when the teacher exports the data, is it just for his or her class? Or is there a way for a researcher to get
It's a good question.
I think I asked it to you like 4 years ago, too.
And it's changed a little bit. So the simple answer is not really. So in LMS land, the data model relies on this concept of a course, and a teacher is in charge of the course. And I can't unilaterally behind the scenes go and do things across multiple courses. The teacher is in charge of their course. But what we do now is we allow sharing of experiment files. So like if you've developed an experiment in one course, then you could press an export experiment button. It's there, export experiment button, and then you could easily import that into a different course. So it makes collaboration relatively easy. Or if you want to do things across multiple of your courses, like across semesters, it's easy to replicate. Yep.
I wanted to go back to your, like you're characterizing it as sensitivity to uncertainty. But if you go back to your histograms, I think there's a slightly different take on the histograms that make it a little bit different of a visualization than all the other ones. So the histogram, in some ways, I actually think that if you ask people, what's the standard deviation of this? They would be terrible at that task, right? I think what they're sensitive to is maybe the distribution or the shape of the distribution more than the standard deviation per se, although, obviously those two things are related. And so my question is, all your other visualizations really are showing something more like standard deviation or, whatever the margin of error idea is in credible intervals, right? And but the histogram one feels a little different to me. How about you? What say you?
I agree. Disagree, just as a general rule, disagreeing with G is a bad idea. She fights and she fights nasty. I'm going to make a broad statement in response to your question. I think you're totally right. I think that when people are making judgments about graphs, they're basically using visual heuristics. So like if they're making a judgment about the difference between instructor A and instructor B, they're just looking, is one higher than the other? And the error bars play a minimal role in that judgment. So it could be a weighted possibility in their decision, but it's not really the primary heuristic. That heuristic falls apart here. They're doing something fundamentally different. And I actually think that that's part of the reason that I think that we should be focusing on education and not just on the design of things, because there's always going to be poorly designed visualizations. It would be great if we could control every person who ever makes a graph, but that's probably not likely. So better would be to train the people who are going through compulsory education, helping them become accustomed to what these heuristics are, maybe helping them see when those heuristics could fail them and what ways that we could, help to short circuit some of those strategies that might get them in weird places. I don't know. Okay, you're going to do the thing. Okay.
I think you actually addressed some of what I was going to ask you about, was just building on G's question, because you did successfully bait me into asking you about this lack of a relationship between stats backgrounds and sensitivity measured in this way. And I guess like maybe to widen the fight, maybe think about who's at fault. Okay. So one possible culprit is that like the knowledge about those like visual heuristics, the concept of standard deviation just never gets in people's heads to begin with. It's like when we're teaching stats, we're just not doing our jobs. Okay. Another possibility is we're doing our jobs, but for whatever reason, when they sign up to participate in this study and apply their knowledge that's in there, it doesn't transfer to this particular decision-making context. Third possibility is that there is a strategy for communicating uncertainty that is very popular, which is to use error bars to indicate uncertainty in estimates of specific parameters of interest that is not the same as the data distribution that is at fault. And that's like another take that one could have that I can imagine some folks here in the Viz community being sympathetic to. So it's like error bars are at fault. Error bars are silly. And like, I'm just curious, like, where do you point the finger? Sorry to put it that way.
It's a good question, and it's funny because my answer is going to make it seem like the students are at fault. Because I think that the answer is to improve statistics training so that it provides practical utility for this. But I don't want to suggest that like all students should have known this. So I think that partly it's the teacher's fault for not having this in the toolkit that they were using to teach the stats classes. Again, I feel like people will encounter error bars. I would love to imagine us putting together a visualization police force, and anybody, like if there's an error bar used in Excel, somebody leaps out of the closet and like tackles them before they do it. But I can't imagine that happening. We need to equip people to know how to deal with the bad stuff too. Yeah. Yep.
A little comment rather than a question, but this result you find with histogram, like it could be people are more sensitive like to dispersion, standard deviation, but it may be also that they are having more difficulty extracting the central tendency, the mean, even though you gave them this information. So that's just a little comment.
Yeah, maybe. So they're
it's maybe like, oh, everything's all around in both cases.
Yeah.
Kind of person.
It does say, like, we intentionally tried to put the mean on the display, but yeah.
Yeah, so I kind of have a little bit of a follow-up to G's question. You framed this in terms of this West and Brozniak result, and you have the ability to look at that because I think your two choices differ in terms of their standard deviation. So do people prefer the option with a higher standard deviation?
It was different. The West and Brozniak study, that presented the critics' ratings as like individual datum. So that like it wasn't the case that there was a summary statistic provided. So somebody had to look at each of the different critics' ratings and then see how clumpy they were or something. So we didn't do that specifically. For that reason, I think that people had to think about West and Brozniak's data a little bit differently than they had to think about ours.
If I may reward myself with the last question, because I'm very curious. So I want to propose a fourth hypothesis to what Judy was talking about. So to what extent do you think people could have issues with pragmatics in here? Because when you're giving them a number that's 4.36, instead of saying 4 or 4.5, why are you giving me these decimal numbers when you're not certain about them, right? So there's a incongruence of like pragmatic pressures of what you're giving, which are alleviated when you're giving it as a plot and a visual representation as opposed to a number, where you have a decision where do you draw the line of how much information you give, which is usually a trigger that we use for assessing uncertainty. Yeah. So what do you think about that?
I don't have a satisfactory answer to that. In fact, when one of the things that I try to teach my students is whenever you run a study, you have to talk with the first participants who pilot it. So get their feelings of what they were doing. And when we were talking with the participants, they kept saying like, what did you want me to do? Like, A was better than B. I chose the A. And they're like, how would the SD even affect that? Yeah, so I mean, if you had to choose a mattress and you wanted to spend $500 on a mattress or something, why would you care about standard deviation if one was better than the other? So I think that there's other considerations also that kind of made them think, oh, this is, the details of what you're doing here are confusing me. And yeah, so I agree with that. It's not a perfect study. Yep.
All right, with that, I think we're closing this session and I can send you on coffee break. Please thank our speakers again.